Welcome back, guys. So our next step we are going to now do, we are now slowly moving towards the k nearest neighbor solution. So now in this video, I'm going to discuss another important part of the solution. So you can see we have already built that solution before recording this video, but now I'm going to explain. So what I'm doing, I have already discussed this parameter in the starting video. So if you haven't watched that, please watch that. And I actually explain why I'm passing the user ID K, and obviously quick recap, K is the number of neighbors which I'm going to use to do the recommendation, and obviously how many recommendation we want to do, right? So that's another important question, that what recommendation we are trying to recommend to this user. And then obviously the number of instance, just to avoid overfitting or underfitting sake, right? So but that parameter we use once we have iteration with real data multiple time, and then we'll see how accurate our recommendations are and how user is responding. So that's where we use the total instance use, right? So and obviously if we have really big data set, and like I mentioned, k-nearest neighbor doesn't work well against the big data set, especially if it has the outliers, right? So keep this thing in mind, but I think at this stage we are pretty good. I'm not going to comment this parameter. Let's start with the next section of the algorithm. Obviously I need to keep the nearest neighbor list. So once I calculate the nearest neighbor, I need to put them in somewhere. I have two options. I can store them into a permanent table, but that will be cumbersome. Like I have to run a lot of insert statement, and it's going to unnecessarily increase the database object. Or if you remember, I discussed the concept of temporary table. I'm going to put that link as well. Please watch that video if you don't understand the temporary table. Now you're going to see how temporary table really help us to build some really strong or powerful solution. Because what I'll do, I'll actually keep that nearest neighbor information into my temporary table, right? In the programming language, we normally use arrays, or the list or all the data structure to keep that information. If you remember, we use the dictionary in Python to keep the information about our candidate or the nearest neighbors. The same concept apply, but in here we are keeping the temporary table. Now obviously the second one is the KNN candidates. Like you can see why I'm using KNN candidates. Now imagine if we have a point. So now this guy and this guy, they have some common interest, right? So that's why they are coming closer to each other. But if I take that point, or maybe if I take, for example, let me just take this point, right? Now this point has no link with our main point, right? So let me just draw that line. And there are multiple reasons why we are saying that this guy doesn't have any interest, because one is the farthest point, or it might be that these two users, they don't have any common interest. So for example, one user is studying physics, the other user is studying, for example, let's say English literature, right? So they're completely two. Or for example, the other person is studying, for example, Spanish or German or any other language, right, which has nothing to do with these scientific subjects, right? So that's why there is no commonality. So I need to filter those of users which doesn't have any interest with this user, right? Otherwise, I have to look through all these users, and maybe those are the expensive iteration which is not going to provide any valuable feedback into my algorithm. So that's why I'm actually I'm keeping only those users which has some common interest with my subject user, which I'm passing to find the k nearest neighbor, right? And that's why I want to keep these candidates, because these candidates are going to be a smaller set compared to the full set. So you can see I've already started optimizing my algorithm, because then instead of searching the 100,000 records every time, if I keep these candidates which have some common interest my user, I can use a small data set instead of a big data set. So that's the reason I'm actually keeping that temporary table. It's gonna retain those user, right? And you can see it has the user ID, ISBN, and book rating. And I'm using the flag use. I'm gonna explain you why I'm using it later. And then obviously, like I mentioned, on the similar pattern, I don't want to actually query my flag table, which is the view in this case, again and again, just to get the information. So we can also use the variable, or what I'm doing now in here, I'm using again a temporary table, which only going to have one row, but I will I will show you that how we are using this one row table effectively to calculate a couple of calculation during our solution, right? So but if someone wants to use the variable, that should be all right, right? Because temporary table is just a one row, so I believe it's not going to be a big issue with my database engine from the performance perspective. And obviously, last but not the least, I want to keep the recommendation, because obviously once the whole solution will finish, I want to store these recommendation into some table, so I can return it as part of the store procedure. And that store procedure will run, I would say, on demand, or it can be run, even on the click of an event. So for example, as soon as user hit the front page of my website or open the mobile app, that store procedure can run and return the recommendation to this user, right? So you can now understand the concept that how we can trigger that store procedure which we are going to create. And I'm going to show you at the very end how you can convert this block into a store procedure. So leave that part for time being. So right now we are in a good shape, like we can understand why I have created these four temporary table, what are the purpose of these four table, and now I'm going to start, feeding the data. So you can see in my user table, which I'm actually showing you, our user ID table. I'm just getting one row, and you can see I'm passing the parameter which I've actually received from my initial parameters. So that's the user which I'm passing, and it's just going to add that row into that temporary table. All right. The next one, this query is now going to be interesting because I want to explain you. And that's where the optimization is coming into the picture, right? So let me just copy it and let me see if I can paste it in here. All right, so because why I put it in a separate window, I want to show you its execution in a separate window, because if I run this block, it's going to execute the whole block. So I want to divide it into chunks. So that's the one. Yeah. Yeah. So you can see what I'm doing. I'm actually inner joining. So X has some ISBN or some books where I have actually an X obviously representing this user. So you can see what I've done. I've actually used my main view, and I'm filtering it based on my user ID, right? So we only have one row actually, which we are going to inner join with all other user except I'm filtering out the user, which I'm passing it to the query. And what I'm using the ISBN. So any other user who have any common entry with my user ID 224108, that user is going to come into the result of this script. And obviously I don't want to duplicate that user again, so that's why in the inner query I'm actually filtering my main user, right? So let me just run it to show it to you. So you can see in here, we have three users who are sharing the common interest with this user, right? So you can see user ID 1167, 203,411, 260067, and 66108. So only these four users, they are overlapping with my user, right? So which is obviously a very exceptional case, because obviously we need more than for user. But like I mentioned, you are seeing so now the reality of the data, and you're gonna see similar challenges in your day-to-day life as a data engineer or machine learning engineer or even data scientist. That these are the challenges we normally face and handle, right? So now the concept is, now instead of, and if I actually show you the total data set. So for example, if I just, if I just run it without any filter, so you're gonna see how many records we are getting. So you can see we are getting 173, right? So now this is a very useful optimization. I filter all those users profile which are not relevant to my algorithm, right? Because I only need those users, because these users are going to be obsolete because of these neighbors which are closer to my user and which has a common interest, right? So that's the concept. All right, so we have discussed up to this point, and obviously then once I add the so these are going to be my candidates, right, which I'm going to actually run my algorithm on to find out the recommendation, right? So that's the one. And then obviously I have I need to do the row count, and if I look at the KNN candidates, which is the list of the candidates which have some interest with my user, they might come in duplicate because they have multiple books. So with each book the user ID is repeating. So that's why I'm using the distinct of the user ID, right? Let me see if I have. I think, yeah, I'm just gonna now show you. Yeah, I can show you in here. Yeah, so you can see we have the unique value. So you can see user ID, we have all the ISBN, and we are getting that information, right? So similar information we have seen in the separate query window. All right, so what I'm doing, I'm just getting the row count, because now I'm going to actually iterate. And if you remember my model equation or my model script that I have discussed in the previous video, now I'm going to run, because I've already seen it is calculating my KNN score correctly. All I need to, just get the user from that list, which I'm, just getting into the candidate list, and I need to iterate to calculate the KNN score, right? So which is pretty simple, single loop. So you can see in here, I'm just now going through, I've already get the total number of users which are available, and I'm now looping it. I'm using while loop, but I have already initialized counter to 1, and it's going to all the way till the total number of candidates. And what it's gonna do, it's first I'm going to get the user into my user ID, because that user ID I need to pass in here, right? So now this user ID, I'm getting it as a parameter, but this user ID is going to be changed when the new neighbor comes into the picture. So you can see in here, I'm actually getting the top one user, and that's why I used one, because once I use this user, I'm going to update this flag to one. So next time I'm going to get a new user, and this will continue until I finish all the users into my KNN candidates table, right? So I'm getting that value into p underscore user ID, which is going to be used for in the calculation. And then now that's the most important part. You can see in here, it is exactly the same equation. The only thing I have replaced the static value with the parameters. And then what it's gonna do, it's gonna add the user ID, which is coming as a parameter, with the neighbor user ID, which I'm representing at C underscore user ID, and the KNN score. It would be anyway. I'll do it. So I'm just calling it candidate, but you can call it end user ID, which normally represent neighbor user ID, and then obviously KNN score, right? So this will do that main calculation. Very important part, because that's why I discussed it in a separate video. And then, like I mentioned, I'm just going to set the use flag to one, because this user have already used to calculate the k nearest neighbor score. So I'm just taking it out from the picture. And now next time, once the loop run, it will get the new user ID from this query, right? So that will do the calculation. And then obviously I'm incrementing the counter. Sorry, the loop is ending in here. Let me just, right? So once the loop will finish, we have all our k nearest neighbor coming in this table, which is obviously KNN list with the respective score. So just for your information, let me just show you what I'm getting from list, right? So now you can see 116. Oh, I need to do it ordered by, so we can see the minimum top. Okay. So now you can see 5.9590, which is 66108. That guy is coming on the top, right? And then obviously we have the three more guys. Then, because we have seen, we only have four candidates which are closer to this one, right? So now we have these neighbors with the KNN score, or k nearest neighbor score. Now we're going to use the next step, where we are going to use that score or the neighbor to recommend those books that this user hasn't read yet, right? So there's a major part of the solution that we have discussed in this video. If you have any question, please post in the comment. More than happy. It's a very critical part, because that's the main meat of the solution. You need to understand, and like you can see, I've already divided it into chunks, so you can easily understand it. I'm going to upload that file, so you can run it by yourself with the data set. So don't worry about the queries and the script. Everything will be available, and I'm gonna see you in the next video with the recommendation part. So thanks for watching, and stay tuned.